So welcome friends. In this video we are going to discuss the conversion of both type of finite automata with output. And I must tell you one thing. For every Mealy machine there exists one Moore machine, and for every Moore machine there exists one equivalent Mealy machine. So any Moore machine can be converted to Mealy machine, and any Mealy machine can be converted to Moore machine. So first we will discuss uh, we will see these two type of conversion one by one, and we will start with the Moore machine to Mealy machine conversion. So I have taken one example Moore machine here. So as this is Moore machine, so output would be associated with each state. So you can see here, friends, these are the input symbols and these are the states. So three states are there, two input symbols are there, and these are the transition table, transitions for each input from each state, and these are the output associated with each state. So you can see, friends, with Q1 we have 0, with Q2 we have 0, and with Q3 we have 1. So one more important thing I must tell you before starting the discussion of this table. See, friends, in the any Moore machine or Mealy machine, the output input symbol and output symbol both may be the same also, but there would be separate set for these. So like in set of all input symbol, the member would be 0 1, and for all set of all output symbols, the member may be 0 1. So these two type of symbols are written separately, but they can be same or maybe different. So in this case also you can see the number of inputs are 0 and 1, and as well as the number of outputs are also 0 and 1. So here in this example these two are same. So now we can see how we can convert this Moore machine into Mealy machine. As you know, friends, with Mealy machine, that output is associated with each transition. So with each transition, we need to have one output value or output symbol. So here I would make the output transition table of equivalent Mealy machine. The number of states would be there same as Q1, Q2, and Q3, and 0, and along with this 0 output would be there output, and 1, and this is another input symbol, and with this corresponding output would be there. So this is the table of Mealy machine. So we will convert this Moore machine to Mealy machine. And friends, as you can see, I am using here the tabular representation of Mealy and Moore machine. So it is very easy to convert from tabular representation. So I will recommend all of you to use this only. But as you practice so many questions there, so then you can directly convert from graphical representation. So no issue is there. But for beginners, it is recommended to use tabular representation for the same. So this is the Moore machine, and I'm going to convert this to Mealy machine. So you can see, for all transition, next state we will write as it is, as they are in the Moore machine table. So for a 0, if we are getting on Q1, if we are getting 0, so we are staying on Q1. So on Q1 we are getting 1, so we are going to Q2, and then on Q2 we are going to 0. On Q2 if we are getting 0, so we are going back to Q1, and on Q2 if we are getting 1, so we are moving to Q3, and on Q3 if we are getting 0, so we are going back to Q1, and on Q3 if we are getting 1, so we are staying on Q3. So these are the transitions that I have taken from this Moore machine table. Now, what I need to write here, the output symbol for each transition. Now you can see, friends, based on the next state or the next state, we can use the output symbol of that particular state. So here you can see the next state is Q1. So I can use the output symbol of Q1 here as 0. Now here also Q1 is there, so I can use 0 here. And for all Q1 we will use 0. For all Q2 we will use 0 here, and for all Q3 we will use 1. So it is Q2, so output symbol associated with Q2 is 0, and it is Q3, so it is having 1 with this. So this is the corresponding table for Mealy machine. So you can see, my friends, this Moore machine is now converted to Mealy machine. So I hope it would be very much clear to all of you. And as I told you, it is very much easy to convert from Moore machine to Mealy machine, but reverse conversion is become sometimes tricky. So that I will explain. Don't worry about it. So now I'm going to take the reverse conversion from Mealy machine to Moore machine. For Mealy machine to Moore machine conversion, I will take two examples. So friends, now we will see the conversion of Mealy machine to Moore machine. Now I have taken one Mealy machine here as an example, and as I told you, using tabular representation becomes easy. So I will use the tabular representation of the same. And now this is Mealy machine table. So I will create one equivalent Moore machine table from this. So before starting the conversion, you must see the table of transition table of Mealy machine very carefully, and especially you check whether every time in state only one symbol is associated or two different symbols are associated with one state. So in this particular Mealy machine, you can see with Q1 every time 0 is there. Every time 0 is there. And with Q2 every time 0 is there. And with Q3 every time 1 is there. So always there is only one symbol with one state here. So in this conversion, no problem is there. It is very easy. And now I will tell you how to do this conversion. So I can write here, like I can create one table for this. So this is our initial state. This is our initial state. So in this particular, again I will create Q1, Q2, and Q3. So as I told you, first check whether single symbol is associated with each state or multiple symbols are associated with each state, right? So if single symbol is associated with each state, then you can have the number of states as it is. Uh, so I can use here in the transition table like this. So see friends, here we will create the transition for 0 and 1, and we will attach one output symbol with each state. So how we would be doing it, let's see. Now on Q1, if we are getting a 0, so we will move to Q1. And on Q1, if we are getting 1, so we will move to Q2. So transition, the next state we will use as it is in the as in the media machine table. So Q2, so it is Q1, and on Q2, if we are getting 1, so we are moving to Q3. On Q3, if we are getting 0, so we are moving to Q1. And on Q3, if we are getting 1, so we are staying on Q3. So now this is the transition table we have completed. Now we have to attach the output symbol with each state. So as I told you earlier, like you have checked it already that with each state only one symbol is associated, like with Q1 or always 0 is associated with each Q1 here. So I can simply write 0 as output here with this particular state. Now with Q2 only single entry is there for Q2, so it is having 0 output, so I can attach 0 with the Q2. And on with Q3 two entries are there, and in both the entries output symbol associated is same, that is 1, so I can write here 1. So now, friends, this is the equivalent table of Moore machine corresponding to this Mealy machine given. So I hope it is very much clear to all of you. And you can see while converting from Mealy machine to Moore machine, we need to check whether the output symbol corresponding to a state are same always or different. If they are same, then it is very easy to convert it like this. Now, if the output symbol associated or with single state are different, and or you can say with single state multiple output symbols are associated, then how to convert such Mealy machine to Moore machine? That I'm going to discuss now. So, friends, now you can see one more example of Mealy machine to Moore machine conversion. And as I told you, you need to check before start converting. So, for output symbol associated with each state. So now we can check. So in this machine, we have four states Q1, Q2, Q3, and Q4, and we have 0 and 1 as input as well as 0 and 1 as output also. So now this is the transition table, and these are the input symbols. So now I can check before starting conversion. I can check whether only one symbol is associated with each state or different symbols are there. So here I have Q3. Here I have Q3. So how many entries are there for Q3? Only two entries are there for Q3. And each time with Q3, 0 is associated. So no problem is there. Then on Q1, we have two entries of Q1. So every time one is associated as output with Q1. So because of this Q1 also no problem is there. And now on Q2, 1 and 2 entries are there, and here you can see output as 1 and here you can see output as 0. That means the output associated with state Q2 are different. And also we will check Q4. So one entry is there for Q4 and one entry is here for Q4. So with Q4 also 0 and 1, two different output symbols are associated. Now in this particular type of machine, we need to use some different technique. So that I'm going to tell you how we can convert this particular Mealy machine to Moore machine. Now friends, the states where only single symbol is associated as output, we will have those states same as they are in the Moore machine also, and the states which are having more than one output symbol associated with them. So we will divide these states for each input output for each output. So now I will tell you how to do it. So as we have seen here, Q1 was having only one output symbol associated, and it was initial state. So I can have only one Q1, and as Q2 is having two different output symbol, so I can divide Q2 as like this: Q2 with 0 as output and Q2 as with 1 as output. So I have divided Q2 state in two separate states: Q2 0, that means Q2 with 0 output, and Q2 with 1 output. Now Q3 is for both entries of Q3, output associated is same. So we will use the only one Q3 here, and we have seen for Q4 also two different output symbols are there. So we will now divide Q4 also in the same way. So Q4 with a 0 output and Q4 with 1 output. Q4 with one output. So I have used here in, you can see my friends, you can see here I have used six different states here, while in Mealy machine only four states were there. So it happens sometimes when output symbols associated with each states are more than one, then you can have more number of states in equivalent Moore machine. So no problem is there. But now try to understand how we can write the transition table here. Now you can see here, friends. So we have 0 and 1 transition for this, and now with each state we will associate with one output symbol. So I'm writing here out. Now you can see here, on q0 if we are getting 0, on q0 if we are getting 0, so we are having q3. So we will write q3 here. On q1 if we are getting a 0, sorry, 1, so we are getting q2. Now which q2 we are having? There are two q2s. So which q2 we are having? So we are having q2 with 0 transition. q2 with 0 transition. So I can write here q2 0. q2 0. Now on q2, we are having q1 as uh, on q2 if we are getting 0, so we are moving to q1. So in both q2 states, mm, we will use the same transition. We are moving on q1 only. And now you can see on q2 if we are getting 1, so we are moving to q4. But which q4? Two q4 are there. So q4 with 0 output. So I can write here q4 0, and as well as here also q4 0. Now I on q3 I am getting on z if I'm getting 0 on q3, so I'm moving to q2. But here which q2? With output 1. So I will write here q2 with output 1. And now on q3 if I'm getting 1, so I'm going back to q1. So q1. Now on q4 if I'm getting 0, so I'm staying on q4 itself. But which q4 we are staying on? So we are staying on q4 with one output. So for both the transition I will write, for both the states q0, q40 and q41, we will write the same transition here. Now in q4 if I'm getting 1, so I will move to q3. So again I can write here q3. Now we have created the transition table. We have created the transition table. Now only one task is remaining, that is associating output symbol with each state. So now you can see, my friend, in Mealy machine table with q1 only 0 was associated, with q1 only 1 was associated each time. So with q1 we can have 1, because with this q1 1 is there, with this q1 1 is there, so I can associate 1 with q1. Now on q0, q2 0, we are already specified which kind of output it is associated with. So q2 is associated with 0, q21 is associated with 1, q3 q3 is associated each time, q3 is associated with 0 only. So q3 will be associated with 0. Now for q40 again 0, and q41 1. So this is the corresponding table for Moore machine, and this is how we can convert Mealy machine where single state is associated with multiple output symbol into equivalent Moore machine. I hope this would be very much clear to all of you. And again, if you have any kind of doubt, you can always write to me in comments, and I will definitely reply your comments. Thank you. Thank you so much.